طيب بسم الله الرحمن الرحيم. So we stopped here last time. This is the taxonomy or the categorization of the data link control protocols that we have, and we said that we divide these into two categories. The category for noiseless channel, and by noiseless channel we mean that channel that's perfect. It does not have any it does not cause any errors to the frames that are transmitted through that channel. So in that case, we don't need any error correction technique. And because as we said, the data link control protocols, they perform flow control and error correction both at the same time. So for noiseless channel, it's simple because I'm not expecting any errors. Therefore, I don't have to wait for any acknowledgement because, for error correction. I don't have to wait for acknowledgement to indicate whether there was an error or not. And then for noisy channel, there is a possibility that an error would happen, in which case I have to first detect whether there was an error or not, and then if I detect that there is an error, then the simplest way to resolve the error is just to retransmit the same frame. So we have two techniques in that category, and we have three different techniques in that category that we need to talk about. So for the ideal channel, we don't expect the channel to cause any loss, any frame loss, or any duplicate, or any corruption to the frame, which is not practical. We know that, okay? But this is just to show you the simplest case. This is the happy path, or the best case scenario, that we don't have any noise on the channel, in which case the channel is perfect. In that category, we'll discuss the simplest protocol, and that protocol does not really have an actual name, and that's why we use a very simple keyword, simplest protocol, because this one is the simplest. You don't have any simpler than this. And then we'll see the problem in this protocol, which we will try to resolve using the supplement. So for each of these protocols, for all the protocols, what I'm going to say now is applicable for all protocols, not this protocol. The best way to understand a protocol is to first think about what are the events that this protocol needs to process. Okay. What are the events that this protocol needs to process? Okay. For the simplest protocol, the way it works is that the network layer, okay, creates what we call a packet, right? And then the network layer would pass this to the data link layer, which will hit the data link control sublayer. And the first thing that the data link control sublayer will do is to do the framing. So it will create the frame, including the header and the trailer, and it will put the delimiter or the flags, as we have discussed before. Okay? And then it will try to send it. So here, the only event that I have to wait for is if there is any data coming from the higher layer. Right? This is what I have to wait for. If there's no data coming from the higher layer, then I don't have to do anything, right? I don't have to do framing, I don't have to create a frame and send it. I don't have to do anything, right? So always ask yourself, what are the main events that this protocol needs to process? The other thing is that, and again, this is applicable for all protocols, not just this one. The other thing is that in all our discussions, we will designate the left-hand side as the sender and this right-hand side node as the receiver. In practice, that's not the case. The sender is actually a receiver, and the receiver is actually a sender. So the data link control or data link layer is by default bidirectional or full duplex. In which case, data is flowing in this direction and in this direction. So at some point, this is a sender, but at the same time, it might be a receiver for the data coming from this node. To study these protocols in a bidirectional manner is rather more complicated. And that's why we will take one direction, okay? And then the bidirectional case is just the same protocol but working in both directions at the same time. So if, for example, I have packets flowing this way, if that works as a sender and as a receiver, the receiver at some point may need to send some acknowledgement that I have received some data. Okay? So if this protocol is working in both directions, what will happen is that I will send the data, and at the same time, in the same frame, I can acknowledge another data. Okay? And that's why we say it's a little bit complicated. And the simplest way or the easy way is just to discuss the one directional case, and then at the end we will show you the graph that shows the bidirectional case using what we call piggybacking for the acknowledgement. So for the simplest protocol, what we need to do is to wait for one single event, which is one packet coming from the higher layer, right? In which case we need to create a frame and send it. And whenever we have any packet, we just create the frame corresponding to that packet and then send it. So the protocol is simply waiting for an event. Okay, so an event is represented in gray. Okay, and then the algorithm will wait for that. If the event happens, then what it will do is that it will grab this packet, it will create the frame corresponding to that packet, and it will send it. The receiver on the other side will wait for a notification of arrival on the physical layer, right? Which will come to the physical layer, and then the algorithm in the data link control sublayer, what it will do is that if there is an event that says there is some data coming on the physical layer, then this data, I'm expecting this data to be in a form of a frame. What I need to do is to process this frame and extract the data from this frame and send it up. Okay? So in other words, the sender is waiting for one event to get data from the higher layer. The receiver will wait for one single event, which is a notification of data arriving on the physical layer. So always ask yourself, what are the events that I need to process for this particular protocol? So in that case, the data link control will get the data and will send it right away in a form of a stream, back-to-back frames. So as long as I have data coming from the higher layer, I always create frame and send it, create frame and send it. Okay? So that looks like in a pseudocode. So any algorithm that runs in any layer will have to have a loop forever, which is what we call the event-based algorithm. The event-based algorithm is always looping. It works all the time. It works as a service in the background. So I need to always have a forever loop. So while true. Nothing can stop this service from running. Okay? And then what I need to do is just to wait for an event. So wait for an event is a function that we call it a blocking call. A blocking call meaning that I will never get out of this function unless an event happens. Okay? So it's like you get to this loop, you get to this function. Once you get to this function, everything will stop, and then we'll wait for an event to happen. Which means that Of course, I have to run this algorithm in a separate thread, if you know what thread is, right? I have to run it in a separate thread. Otherwise, if I run it in a program, then the whole program will halt. So I have to instantiate a thread, okay, and then run this algorithm within that thread. Okay, so it does not block the functionality of, of the other layers and other services that runs in parallel. Okay, so this is like a programming tip. So if that function returns, the first thing I should ask myself is that, what is that event? Is that event one of the events that I'm waiting for or not? So you have to filter out this the events. Okay, is that event, it's an event for request to send, or in other words, is this a data coming from the network layer that needs me to send? Because there could be some, we will see there are tons of other events that might happen. But in that particular protocol, I don't need to deal with all the other events. I'm just waiting for one single event. That's why I actually told you, and I repeat that the most important way, or the easiest way to understand these protocols, is by asking yourself, what are the events that this protocol should process? And all these events will be in a form of if statement, big if statement. Okay? And it always works this way, as we will see later. Inside that if statement, which means that I received an event, and the event is one of the events that I'm interested in. What do I need to do here? As simple as I need to get the data from the buffer of the network. I need to get the data, because the network layer, what it will happen is that it will put this data in a buffer and then create the event or initiate the event. The data link control will go to that buffer, will get the data, and the next thing it should do is that it should create the frame corresponding to this data. Okay? So first, I should get the data from the buffer. Second, I should make the frame, which means do the framing, whether it's bit stuffing, byte stuffing, and I need to create the header and trailer, okay, and fill all the fields and stuff. And then, once I create the frame, I should send it. That's all I need to do. Okay? So this is the simplest way. So loop forever, wait for one single event. If the event comes, just get the data, grab the data, make the frame, send it. That's it. Okay? So I don't need to do anything special. However, again, I'm waiting for one single event. Once this event happens, I should ask myself, is this the event I'm interested in? If the answer is yes, then I'll do the reverse operation. Get the data from the physical layer. The data is in a form of a frame, remember. Okay? So I should do the reverse operation. The reverse operation is that since the data is in the form of a frame that looks like this, so you have the data, and you have header, and you have trailer, and you have flag, or the delimiter on both sides. What I'm interested in to send up is this part only, right? So what this function will do is that it will extract this part, okay, and then it will deliver this to the higher layer. As simple as that. So this is what this extract data will do. Extract meaning get the data from the frame. Of course, after you have to process the header, you have to process the trailer to make sure that everything is fine. Okay? We'll see that later. Because here, I'm not expecting any error to happen. Remember, here, I'm not expecting anything to happen because the channel is perfect. So supposedly here, if there is an error, then I need to do something. But since we're talking here about noiseless channel, the channel is perfect and I'm not expecting any error to happen. So that's why I don't need to do anything special. So extract the data, deliver it, and by deliver, I mean deliver up to the network layer. So that's simple. So the figure after that will show you this sequence in a timing manner. We'll show you how like in a timing manner. So we have we have the sender and we have the receiver. And in the simplest protocol, what happens is that if there is any request to send event, I create the frame and send it. Okay? And then if the data is backlogged or if the data is skewed on the sender, this means that these frames will be sent back to back. Right? With no gap in between. Okay? So I will send the frames because if the sender has so many packets or so many frames waiting in the buffer, what will happen is that the network layer will grab the first packet, create the event, grab the next packet, create the event. So the sender will then have to process these events back to back with no gap in between. Why am I saying that? Is that in the simplest form that we see here, there might be a problem. Because if I send these frames back to back, okay, it looks like you're sending a big flow of water in a pipe that's very small. So what will happen? The pipe will take what it can carry, and the rest will be wasted. Or even if the channel or the pipe can get the flow of water, maybe the other side cannot consume the water with the same speed, in which case again the receiver will consume the frames that it can absorb, and then it will not process the rest. Okay. So the simplest protocol has an obvious problem that if the sender is sending these frames very fast, then the receiver cannot cope with it. In other words, the simplest protocol does not have any flow control. Okay? So the simplest protocol does not have any way of flow control. It does not control the flow. Okay? It sends the frames with the same speed that it receives from the higher layer. So if the higher layer is sending like video data, which is like big chunk of data in a very short time, what will happen is that the sender will keep sending this chunk of data as they arrive, which might be too much to the receiver to consume and absorb. So that will create one of two scenarios. Either the receiver will be highly pressured and it will be, we call it jammed or chopped, okay? Or the channel itself will be congested, okay? If the speed of the sender is not really controlled. So in the simplest protocol, we don't have any flow control. Okay, so this is the simplest way possible. Once they arrive, I just get the data and send it above. Get the data and send it up in the stack. That's it. And there could be a potential problem that we talked about. So we need to resolve the issue of flow control. So one way of making sure that the flow that I'm sending can be consumed on the other side is what? Naturally, okay, in order for me to control the flow, then I should always wait for the receiver to tell me whether it can actually absorb this data or not. Okay? So this is what we call stop and wait. So in stop and wait protocol, I will send a frame and always wait for the receiver to tell me whether the receiver has received this in a reasonable way, which means that, again, remember, we're talking here about noiseless channel. We're not talking about error here. So here I'm waiting for the receiver to tell me that it finished processing what I have sent. Okay? Because this is the only way for me to make sure that whatever flow I'm sending can be consumed on the other side. So what stop and wait protocol does is that it sends one frame and wait. Wait for what? Wait for an acknowledgement. Remember that acknowledgement here is not for error correction. Acknowledgement here is for flow control. Is to tell me, okay, I consumed the first frame, send me another one. Okay? And I always have to receive that acknowledgement. And the acknowledgement for me indicates here that I was able to absorb this one, which means I'm ready for another one. Okay? So remember that for stop and wait, the purpose of the acknowledgement is for flow control, because later on we will start complicating this a little bit more. So in that case, again, to be able to understand and visualize how this algorithm works, again, ask yourself, what are the types of events I'm waiting for at the sender side and at the receiver side? Well, at the sender side, I'm waiting for, again, to get data from above, or I'm waiting for the event that I have some data to send, right? And also, I'm waiting for another event, which is, I'm waiting for the acknowledgement. So in that case, I have two events. One is coming from above, from the network layer, to tell me that take this data and send it. And the other one is from the receiver, which means from the physical layer, to tell me that there is a notification for an acknowledgement that arrived from the receiver. Okay? And here, the algorithm, what it does is that if it receives data from here, it sends the data and waits for acknowledgement. And the reason for that is that I don't want to keep sending all the time, okay, and jam or congest either the channel or the receiver. I don't want to do that. I don't want to do either. Okay? I want to send with the pace that I'm sure that the channel can absorb and the receiver can absorb. Okay? So here I'm waiting for two events. One is to get data from the network layer, and the other is to receive acknowledgement from the receiver. The receiver on the other side is waiting for one single event, which is I get the data. Then what I need to do is that I need to receive this data and send it above. But before I send it above, I have to send the acknowledgement. So the acknowledgement here is not an event. I'm waiting for one single event, and then once this event happens, I send up and I send down the acknowledgement, both at the same time. Okay? So this is how it looks like in pseudocode. So again, I have the forever loop, and then we have what we call allow the first frame to go, which is the can send equal to. We'll talk about this. What do we use it for? The can send. Because again, I cannot, if I receive one frame and then another frame, okay, I have to wait for an acknowledgement before sending the second frame, right? So if I receive a request to send from above and I did not yet receive the acknowledgement, then I will not process that event. That's the difference here. That's why I need someone to tell me whether I can send or not. So that's this flag. We'll see how it's used. So if I have a request to send, then what I need to do is that, again, get data, create frame, send it. But then I have to block any further transmission. Right? That's the difference here. In the simplest, I don't have to wait for an acknowledgement. So everything that comes, it goes. Here, no, I have to wait for something to happen before I can send another frame. And that thing is actually the arrival of the acknowledgement, which is the second event. Okay? So if I receive an acknowledgement, then I can set the can send to true, which means now I can send. But if I receive a request to send, then the first time what I will do is that I will set this to false. If the second event is actually a request to send, what will happen? It will go here and it will say, okay, is this a request to send? Yes. Is the can send true? No. So in which case, I will ignore it. صح? So in that case, I will ignore it. So only if I receive an acknowledgement, I will set the can send to true, which will then get me through this if statement. معايا؟ تابعين؟ Okay? So that's the difference here, is that I have two events, and only when that event happened, I will be able to go through that event and process it. So the advantage of this is that here there is a flow control mechanism. I'm sure that whatever I'm sending, the receiver on the other side is absorbing. It can absorb, it can consume. Okay? Unlike the simplest way, which I'm chopping I'm throwing all the data that I have to the receiver without having any guarantees whether that receiver will be able to cope with that or not. Okay? So this is like, so this is the receiver. So again, the receiver has, as we said, the receiver has one event. Okay? So when it receives the frame, it will extract and deliver the frame to above. And then this is the acknowledgement, bravo. So that tells me that you're following. So this is the extra step that I have to do. I have to send an acknowledgement. And again, because this is a noiseless channel, I'm not expecting any error to happen, neither in the data nor to the acknowledgement. I'm not expecting any problems to happen. This is the ideal case. Okay? So this is like in the timing diagram. So the sender, when it receives the request to send, it will send the frame right away, and here it will wait. Okay? Wait for how long? Forever. Forever. Why?
Looking for.
Yeah, it's blocking. You're right. But also, I'm always expecting to receive the acknowledgement. Why? Because again, the channel is perfect. So I'm sure the frame will arrive and the acknowledgement will come back. That's for sure. Because again, the channel itself is perfect, which is again not practical, but that's the assumption here. Just to go gradually and complicate things as we move forward. So I'm getting the event to send the data, so I'll send it and then wait forever. When I receive the acknowledgement, then I will declare that this is the arrival of the acknowledgement. In that case, I can send the next frame. When it arrives, remember that between here and here, I can have some gap, I can have some silence, depending on whether the event from the network layer has come or not. So this is event-based, so I always have to receive the event, in which case I have to process it by sending the frame and wait for the acknowledgement, and so on. Okay? On the receiver side, I can simply wait for the arrival of data. What I'm going to do is that simply I will send this above, and then I will send the acknowledgement back. It's one event. I don't have to wait for any other event. So I need someone to tell me what is the problem here, if there is any problem. So this is this is for noiseless channel. And this is a guarantee for me that whatever I'm sending, it's actually absorbed by the receiver. So that's good. So what is the problem here?
What if I don't get an acknowledgement?
I'm expecting to always get the acknowledgement because the channel is perfect. So I'm sure that the receiver will always send me the acknowledgement, and I'm sure that the acknowledgement will never have any problem arriving back to the sender.
It's an overhead to receive an acknowledgement every time for every frame.
Getting close, yeah, that's good. Yeah, so that's one problem, yes. So I always have to wait for acknowledgement for every single packet. So that's a big overhead, right? And remember that during this time, I'm not doing anything, right? During this time, I'm not doing anything, which means that this whole gap, I'm not using the channel for anything. I'm just sending the frame and waiting for the acknowledgement to arrive. And I'm not sending anything in this gap. So if the time that the frame takes to go all the way to the receiver and the acknowledgement to arrive to the sender is long enough, this means that these gaps are going to be larger and larger, in which case the sender is not actually utilizing that channel efficiently. Okay? So if I have the ability to send multiple frames, as you said, multiple frames, then this would be better. But again, if I do that, then I go back to the simplest protocol, which does not have any flow control, right? So somehow I need something in between. I need something to allow me to utilize the channel efficiently by sending multiple frames at a time. But I also need the receiver to tell me, to indicate to me that it's actually absorbing what I'm sending. Okay? So this is similar to if I need to make sure that the flow of water is reasonable, I have to drop one drop of water and just wait for someone to tell me whether this has reached on the other side or not, which does not make sense. So a more efficient way is just to pour the water in a more in a faster manner, okay, but enough to make sure that it's going on the other side without really pouring the whole water in the pipe, which might cause some problems. So I need to send multiple frames at a time, but I also need the receiver to tell me whether I'm sending is actually being absorbed or not. So I need, as I said, the two protocols that we talked about are two extremes. One is the simplest and it does not have any flow control. This is the stop and wait, which is very conservative, very strict. It does flow control, but in the worst case possible. Why? Because for each single frame, I have to wait for a very long time until the acknowledgement happens, which does not really give me the flexibility to utilize the channel efficiently. So that leads us to the three possible enhancements which take into consideration what we have discussed now, and at the same time they work for the noisy channel. For noisy channel, I may expect, or I can expect that errors may happen. And when the error happens, it might happen to the frame itself while it's going from the sender to the receiver. It might happen to the acknowledgement that comes from the receiver back to the sender, right? So it may happen to either of them. So I need the sender to be able to detect when and if the error happens, okay? And then if it detects that the error happened, then it needs to simply retransmit the same frame, okay? So, so the way that this works is that when I take a frame to send it, I have to keep it aside first, right? Because I have to make sure that it arrived correctly. The way for me to make sure that it arrived correctly is by receiving the acknowledgement. Which means, or which indicates that the acknowledgement here will have one extra purpose. So we said that the acknowledgement indicates to me that the receiver can cope with the speed. Now, the acknowledgement turns to have another functionality, which is, it tells me that the receiver has consumed the frame, and the frame has arrived successfully. Because it may happen that the frame will never arrive successfully, right? Which gives a very high importance to that acknowledgement now. So the acknowledgement now will tell me that the receiver can cope with the speed, and the receiver has actually received this frame successfully, which may not always happen. So for noisy channel, first we'll talk about the first protocol, which is the stop and wait with automatic repeat request. So automatic repeat request is for error correction. Okay, so this is the stop and wait, which means that, again, I will send one frame, wait for the acknowledgement. But then automatic repeat request talks about the fact that I have to detect whether an error happened or not, and if the error happened, I have to retransmit. So error correction in stop and wait automatic repeat request is done by keeping a copy of the sent frame. So the first thing I have to do is that I have to keep a copy of the frame. Why? Because when I send the first frame, it depends whether the receiver has received it successfully or not. Which makes the next step to have two possibilities. Either I will send the next frame, or I will send the same frame, right? I will send the same frame if an error happens. I will send the next frame if no error happens. Right? So in that case, I have to have two buffers in that case. So what will happen is that in the network layer, I have these packets stored one after the other. So what will happen is that in the data link control, I will take this frame and then I will copy it in a side buffer. Why do I have to do that? Because it may happen that I don't receive the acknowledgement correctly, in which case I don't need to go to this buffer. I need to go to this buffer and send it again, which is what we call retransmission. So in order for me to retransmit the same frame, I have to have a copy of it. Okay? So I take one data packet, and then I store it, and then send this frame. If that frame arrives successfully, and then I receive the acknowledgement, then what will happen is that I will declare this as sent successfully, and then I will go to the original buffer from the network layer and get the next frame. If that frame did not arrive to the receiver successfully, which is indicated by the fact that I will not receive an acknowledgement, right? In which case, I will not go back here. I will get this frame and send it.
The copied one?
The copied one. Because the copied one is the current frame that I'm trying to transmit. If it fails to be transmitted the first time, I have to try again. If it fails again, I will try again forever. Okay?
Waiting for the acknowledgement, like for there's a specific time, if not.
Bravo عليك. So see, now, because I said that the frame may never actually arrive to the receiver, right? In the first case, I waited forever because I'm sure that the channel is perfect and I will always receive the acknowledgement. It's just a matter of time because the channel is perfect. But here, the channel may have an error, in which case the frame may never arrive to the receiver. Or even if the receiver received that frame, the acknowledgement from the receiver again may never arrive back to the sender. So there is some possibility that either the frame will not arrive or the acknowledgement will not arrive. So in that case, I cannot wait forever. I have to have a limit. Okay? So this is the third event. So here, in stop and wait ARQ, I have three events now. I have get data or request to send from the network layer. I have arrival notification of the acknowledgement. And then I have another event which is timeout. You waited for enough time and the acknowledgement never arrived back to the sender. Okay? So I have three events in that case. So that looks like, so we, the other thing is that here we use a sequence number. Why? In the normal stop and wait, we didn't have to use any sequence. Sequence number is what? It's like you're numbering your frames. This is frame 0, this is frame 1. What is the purpose of this? Well, the purpose is that, remember, for stop and wait ARQ, you have two possibilities. If you receive the acknowledgement correctly, then you send the next frame. If you don't receive the acknowledgement correctly, then you send the current frame. So you have to distinguish between these two frames. So the only way for you to distinguish that this is whether this is the next frame or the current frame is to number them. That's why we need a sequence number. But the sequence number here, we need just the sequence number to tell us whether this is the current frame or the next frame. That's it. Which means that we only need two numbers, really. This is the current frame, this is the next frame. That's it. We might actually use, in that case, we can use label, this is the current frame, or this is the next frame. But we are using the sequence number here because this leads us to what will happen after that, is that this sequence number will start being used in a more sophisticated way, as we will see later. So we use a sequence number, and that's why we say that this sequence number is modulo 2 arithmetic. What does that mean? This means that the sequence number will go as follows. We have frame 0, and then frame 1, and then when we increase 1 using the modulo 2, what will happen? 1 plus 1, 1 XOR 1 كده is 0, which means that we will go back to 0. So we always need two sequence numbers, really. 0, 1, 0, 1, 0, 1. 0 to indicate always the current frame, and 1 to always indicate the next frame. The current frame I need if the acknowledgement did not arrive. 1 or the next frame is always needed if the acknowledgement arrives successfully. Okay? So this is how. So if the acknowledgement number announced in a modulo 2 arithmetic, the sequence number of the next frame expected. So if I receive the acknowledgement successfully, then I use frame 1, which means that I need to send the next frame. If the acknowledgement did not arrive, then I send the current frame, or frame 0 in that case. So this is the algorithm, and as we said, we have three events. One is get data request to send, and the other is that acknowledgement arrived, and the third one is if there is a timeout, because I cannot wait forever in that case. So whenever I receive a request to send event, I need to send data similar to what we have done before, and then wait for the acknowledgement. If I receive the acknowledgement successfully, then it will come through this way, in which case I receive the frame, which indicates to me that the frame has arrived to the receiver can consume it, and it arrived successfully. In which case, I start getting the next frame and send it, and so on. Unless there is some kind of a timeout happens. If I send the frame and never receive an acknowledgement, in which case, if the timeout happens, this means I have to go back to my copy buffer and get the frame and retransmit it again, the same frame again, which is frame 0 in that case. Okay, so I should go back to frame 0. In which case, the stream of packets for the stop and wait ARQ will always look like this. If I were to have a buffer of frames, so I always have frame 0, frame 1, frame 0, frame 1, frame 0, frame 1, and so on. So when I send this, if I receive acknowledgement, I will send this. Otherwise, I will send the same frame. Okay. If I go here and I receive an acknowledgement, then I should send frame 0 this one. Otherwise, I will send the same frame, and so on. Okay. That's why I need always to keep a copy of the current frame. So that I know that I'm actually here in this point. Okay? So this is how it looks like in a pseudocode. So when I receive a request to send, again, I have to make sure that I can send, which means that I received an acknowledgement successfully. That's why I have to add the can send, which is initially set to true, which means initially I can't send anything. Okay, so I get data, make frame, and then there is one extra step here that I have to do: store the frame in a separate copy. So first I have to store the frame, and then send it. When I send it, I send the current frame. So starting from here, I should have the serial number, and as we said, the serial number is always it always goes 0, 1, 0, 1, and so on. So send frame SN, which means that SN is initially 0, so I will send frame 0, which I have stored at this step. Okay, and then when I send frame 0, I then start the timer. So start the timer. It's like a timer count that it counts until the timeout happens. So hopefully I receive an acknowledgement before I time out. And again, once I start the timer, I will advance the sequence number to indicate that in normal situation I should send the next frame. In normal situation, I should send the next frame. What will happen if I don't receive the acknowledgement? I can simply say, I can subtract 1 from the serial number just to or sequence number just to indicate that I need to send the current frame. So, the next event is the arrival of an acknowledgement. So what I need to do for the arrival is that this is the main if statement of the arrival of the acknowledgement. Then I have to receive the frame at the sender side, okay, and then I have to check the acknowledgement. The acknowledgement number is always the same serial number plus 1, as we will see later. The acknowledgement number here indicates that the receiver is telling the sender, I received frame 0 correctly, send me frame 1. This is what the receiver tells the sender. So the acknowledgement number is always the frame that I just received plus 1. This means that frame 0 has been received, send me frame 1. When I receive frame 1, I will send an acknowledgement with acknowledgement number 0 to indicate that I received frame 1 successfully, send me frame 0, which is the next one. When I receive 0, I send acknowledgement number 1, which means that since I have already sent and advanced the serial number, the acknowledgement number here is expected to equal to the current serial number. Because in the previous slide, I have actually advanced the serial number by 1. So I'm expecting the acknowledgement number to be in the same level like the serial number. So if that's the case, then everything is working fine. And also I have to check that the acknowledgement is not corrupted, which means that I receive the acknowledgement and I can decode that this is an acknowledgement, because it might happen that because we have a noisy channel, it might happen that the frame or the acknowledgement arrives, but I cannot actually decode it because the acknowledgement is actually corrupted. Some of the bits has changed. Some ones have turned to 0, or some 0 have turned to 1, which means that I cannot really recognize it as a proper acknowledgement. So if there's no problem, which means that the frame is not corrupted and the acknowledgement is the same number that I'm expecting, this means that no error have happened. There's no error whatsoever. So in that case, since I'm keeping the timer running and I receive the acknowledgement, I should not keep the timer running because I received the acknowledgement successfully, so I have to stop it. And then when I send again, I have to start it again. So every time I send, I have to start the timer, and then once I receive the acknowledgement, I should stop the timer. Unless I receive this third event before the second event. This means that the timeout has elapsed and I did not receive an acknowledgement. Okay? In which case, we will resend a serial number plus 1, which is the one that I just sent. I'm just trying to retransmit it again, and then start the timer again. And then, if an error happens, then this event will happen again. There will be a timeout. Timeout meaning that again I will send serial number -1, and I will start the timer, and I will keep doing this until this frame arrives to the receiver successfully. In which case, if it arrives to the receiver successfully, then I will go here. It's not corrupted, and the acknowledgement is true, which means that I will stop the timer, purge the frame. Purge the frame here, it means clear the copy buffer. The buffer that I have copied the frame to, just clear it. I don't need it anymore. Because now I have to go to the original buffer and get another one, another brand new frame, because the current frame has arrived. Okay? And then I'll set the can send to true, which means that, okay, I'm clear, I can send one more packet next time I receive the request to send. Okay? So here are 3 events: the timeout, the arrival of the acknowledgement, and the request to send. On the side,
Shouldn't we add the there is a timeout. Set can send to true.
Set the can send to true.
When there is a timeout.
If there is a timeout, okay, this means that the can send was originally false. The timeout does not check for the can event. It will send, right? And then you're supposed to, because you have sent it again, you're supposed to set the can send to false, right? Which is already done by the first event. So in that case, I don't need to check if it's true, and then after I finish, I set it again to false. Because I know that the current value of it now is false. Okay? So I don't need to check it because I know it's false, and I don't need to set it again to false. Okay? So the receiver on the other side will use a sequence number, which in that case it's called a Rn, which corresponds to the Sn. And again, this will increase in a modulo 2 manner. Okay, it will go from 0, 1, 0, 1, 0, 1. And this Rn will indicate the acknowledgement number that I have to send back to the sender. So here I need only one event, arrival of data, right? Arrival of data indicates that I received brand new data. I need to send the acknowledgement and send data up in the stack. Send it up to the network layer. The one extra event here is that I need to advance the sequence number at the receiver side in order to send the acknowledgement with a particular acknowledgement number. This is the acknowledgement number that we have checked on the sender side to see if it's in the same level like the sequence number. So, and remember, if everything is fine and I need to send the sequence number, I will advance it. I will increment it by 1 before I send the acknowledgement, which means that if I receive frame 0, then Rn will be 1, and I send the acknowledgement 1, which is the one that we have checked on the sender side, and we made sure that acknowledgement number equal 1. Okay. So again, the acknowledgement always sends a clear message. I have received this frame correctly. Send me the next one. This is what this sequence number means. Type. If I received the data, and again, the data was corrupted. For the receiver, the corrupted data is as if I did not receive anything. So if a data arrives, and then I checked, and there is a data corrupted, then I go to sleep. Which means get out of this and wait for another event. Go to sleep until another event happens. Because this data has arrived corrupted, it's as if it did not arrive. I don't have to do anything. Okay? And this happens when there is a chance, because we have a noisy channel, there is a chance that the frame will not arrive at all to the receiver. The frame is lost completely. But there is another chance that the frame arrives, okay? But some of the bits have changed. How do we know that? We know that from the trailer. As we have studied in 455, in the trailer, we have some error detection bits that tells me whether this frame has some bits changed or not. So through the trailer in the frame tells me whether the data is correct, or some of the bits have changed from 1 to 0 or from 0 to 1, which might happen due to some noisy effects, as we have studied in the physical layer. The signal might change, frequency might change, things could happen, in which case some of the zeros can be detected as ones, or some of the ones can be detected as zeros, and so on. So the frame arrives on the other side, and some of the bits have been toggled. So in that case, the receiver will detect that this is a corrupted frame. Corrupted frame for the receiver is as if it never arrived, even if one bit is in error. Okay? So in that case, I will go to sleep, I will not do anything, I will wait for another event. So only if the frame arrives. Here I have to check this if statement. If someone explains to me what is the need of this if statement, she will get a bonus. It's very so why do I have to check for this sequence number? First, if I go past this, then this means that everything is fine, right? Which means that I receive the data and the data is correct. Which means what I should do is extract the data, deliver it, and advance the pointer, or advance the sequence number of the receiver side. Okay? So why do I have to check this? True. What causes the fact that it might not arrive in order?
The corruption, copy one.
The copy one. How?
Maybe it's still in the buffer.
Okay.
And it could receive again. Send it again.
Under what condition?
It's acknowledgement. The acknowledgement is corrupted.
The acknowledgement, bravo, Alec. That's true. If the receiver sends the acknowledgement and the acknowledgement is corrupted, for the receiver everything went fine. So I have to advance the pointer. But for the sender, the frame was never sent to the receiver. صح? So which means that the receiver will advance the sequence number, but the sender will not receive the acknowledgement, in which case it will send the same frame. صح? Again, when that arrives to the receiver will be puzzled now. I received this frame before. صح? That's why here I have to check for the sequence, because it might, as you have just said, it might happen that I receive frames in an order that I'm not expecting. And that can happen either because of the scenario that you just said, that I send the acknowledgement and the acknowledgement gets lost, or I send the acknowledgement and before the acknowledgement arrives, a timeout happens, which means that I will send the same frame again. It's the exact same effect. We'll see how this happens in a timing manner. But it may happen that the acknowledgement is lost or there is a timeout, in which case I will send the same frame again, but the receiver is expecting the next one, not the current one. And that's why I have to check that the sequence number of the frame that I'm receiving is in order that I'm expecting. Only then I can process it. Because if it's not in the same order that I'm expecting, then I will ignore it. I will ignore it. خلاص, I received it before. Because I received it before successfully. But then, regardless, I have to send the acknowledgement again. Okay? So even if I receive a frame out of order, I will send an acknowledgement again. Because this is an indication to me, as is just said, that maybe the previous acknowledgement that I have sent was lost. Okay, so send another one to tell the sender that maybe the previous one was lost, so again, this is an acknowledgement to confirm that I have actually received that frame. But I will not extract data, I will not deliver data to the above, and I will not advance the pointer. Because this is a duplicate frame. معايا? So this is a duplicate frame in that case. So this is the timing diagram of this. This is the what we have discussed in a timing manner. So the sequence number here is pointing to frame 0, and here is pointing to Rn is always advanced by 1. To indicate that if I send this means that I send acknowledgement 1. So frame here is 0. When I send an acknowledgement, it's acknowledgement 1 to indicate that I have received frame 0 correctly, send me frame 1. If this was done correctly, then I have received frame 1 correctly, send me frame 0, and so on. So if I sent a frame and the frame was not received successfully, in which case the frame will not arrive and I will not receive an acknowledgement. In which case I will time out. I will send the exact same. So here the serial number or the sequence number did not advance. I will send the current frame and I will keep it the same position. If this arrives correctly, then I will send acknowledgement 0 to indicate send me the next frame. So I'll always do that. So here is the interesting scenario that we have just discussed. I sent the frame, in which case the receiver will advance the pointer, will send back the acknowledgement, and now the acknowledgement was lost. And here I will have to time out. When I time out, I'll send the same frame again. In that case, the receiver, as we can see, will not advance the sequence number at the receiver side. Why? Because this is a duplicate packet. And that's why I have to make sure that what the sequence number of the frame that I'm receiving is in the order that I'm expecting. If I'm expecting frame 1 and I receive frame 0, I will just ignore it. But when I ignore it, as we just said, I have to send an acknowledgement again. Because this is an indication to me that the first one was lost. So I have to send another one. Okay? So this is the sequence if I have a noisy channel. And as we said, the same problem applies to this algorithm when it comes to utilizing the channel efficiently. Because as we have discussed before, this gap is idle. This gap is idle. I always have to wait for an acknowledgement before I send the next frame, which keeps me idle most of the time. Send one frame only and wait for an acknowledgement. So here, I use the acknowledgement to serve two purposes. One is to make sure that the receiver is absorbing the frames that I'm sending, and also the receiver is receiving them correctly with no corruption and receiving the frames successfully. Okay? But again, I'm still not utilizing the channel in the manner that I would hope, because all these idle gaps makes me not able to utilize the channel efficiently. And this example, quickly, this example talks about this scenario. What will happen is that in a stop and wait ARQ system, the bandwidth of the line is 1 megabits per second. The bandwidth is 1 megabits per second. If 1 bit, which means that when the sender sends a bit, it will go to the receiver and come back in 20 milliseconds. Okay, so this single bit will go to the receiver and come back in 20 milliseconds. Okay, which is the round trip time for this bit. What is the bandwidth delay product? The bandwidth delay product, as we have studied before in chapter 2, is simply the bandwidth times the delay. But what does it indicate? It indicates that during this 20 millisecond, how many bits can I send to fill the channel? That's what it means. Okay? So this means that for 20 milliseconds, I can send basically, if I have 1 megabits per second, 1 times 10 to the power 6 times 20 millisecond, which is 20 times 10 to the power minus 3. This means I have 20,000 bits I can send during this 20 millisecond time. Theoretically. So I can send 20,000 bits, okay, to fill the channel during this 20 millisecond. If I have a bandwidth, the bandwidth اللي هو ايه؟ bandwidth اللي هو قطر البايب يعني. This is the radius of the pipe. This is what restricts the flow of water that I'm trying to send. So theoretically, I can send flow of water with a volume of 20,000 bits in 20 milliseconds. Okay? Then another added information is that if the system data frames are 1,000 bits, what does that mean? This means that during this 20 millisecond, using stop and wait, I will send one single frame, right? Because I have to send one single frame and then wait for the acknowledgement to come, right? So I will send one single frame, which is frame 0, and I will wait for 20 milliseconds before the acknowledgement comes, before the first bit of the acknowledgement comes. This means that instead of sending 20,000 bits, which theoretically the capacity that I can send to the channel, the actual scenario, I sent 1,000. So what is the utilization of the channel? It's simply 1,000 divided by 20,000. So I send 1,000 bits as I can actually send 20,000 bits. Right? Because I have to wait for all the round trip to come all the way from the receiver back to the sender. This is actually ignoring the processing time at the receiver, assuming that once the receiver receives, it will send the bit right away, the acknowledgement right away, with no time to process. This means the utilization of the channel is actually 1,000 divided by 20,000. So instead of sending 20,000 bits, I only sent 1,000 bits. So for this particular example, it would be nicer to increase the frame size a little bit, but I cannot. There is a limitation. I'm restricted with a specific length. Okay, so that's why the utilization of the channel, which is in that case 1,000 divided by 20,000, which is 0.05, which means I'm utilizing 5% of the channel only. So this is an indication to me that really stop and wait with ARQ is not efficient, and I need to do something about it. I need to be able to send multiple frames without having to wait for the acknowledgement. Okay? So we'll discuss that next time.